In this video, I had some more functional group transformation reactions that we're going to be working with alkenes. So I made another video, but this just has a few more things that we could do, just a couple more useful things that are nice to keep in mind during synthesis. But anyways, let's start out on the very first one with the arrow pointing up with NBS. And you can either use heat for this or you could use light. Whichever one you used, it doesn't matter for this particular molecule, you're going to get a mess. So there's truly just going to be a mess on this problem, and I have in the description a sheet that shows just some of the possibilities that you could get. I will come back to this one and show you guys um, a more practical use of NBS, but I thought it'd be nice to at least introduce it real quick. Going on to the second one, this is a general oxymercuration demercuration. I hinted on it in the last video. It's just going to add an alcohol to the most substituted carbon. So in this case, it'd be that tertiary carbon, and that's where you'd put your alcohol. It's the same exact thing for this next problem. It's another oxymercuration demercuration, but we're going to use methanol. So the only thing that changed here is we're using methanol instead of water. And when we use methanol, it's going to be our nucleophile here. And we'll get the same exact substitution regiochemistry, but instead we will get methoxide substituting on. So that would be a different way of doing oxymercuration demercuration. This next one is a just general Diels-Alder reaction with a it doesn't have to be something like butadiene. You could use any other diene that you wanted. In this one, we are treating this cyclohexene kind of parent ring like our dienophile. So we should expect this would be our product. Okay, going on to the next, this is a water with some acid, usually used with sulfuric acid. And we know the first thing that will happen is to protonate, and so if you protonate first, you'll be left with a carbocation on the most substituted carbon. So again, we will get an alcohol right here. So it's just, you get the same product as you would in the oxymercuration demercuration. With bromine and water, you start changing up a little bit. So we will add bromine to the less substituted carbon. The reason it's less substituted is because it adds first, and so that means that when it adds, the thing left over is going to be a carbocation, and the best place for a carbocation is, of course, on the most substituted one, which would be tertiary here. It's good to note that this is an anti-addition, so I could say that right here. So this is anti-addition. And since I just wrote that, we know that this alcohol is going to be on a wedge. So you could also say plus the enantiomer. On the next one, if you're just using bromine, and you might have some clever solvent that makes bromine safer to work with, but if the focus is just bromine, then we will do the same exact thing as in the previous problem, where a bromine will be added right here, and another bromine anti to the previous one will be added on the tertiary carbon. So just like that. And again, you could say plus enantiomer. And I guess I should also say that this is an anti-addition. Anti-addition, there you go. So back to this NBS problem. I can show just one real quick example of when it actually would be useful. And it's whenever we're dealing with something that's going to be a little bit more selective. So less H's to pull off, less places um, for double bonds to migrate to. So if off to the side here, if I use something like toluene, and we wanted to put a bromine out on this methyl group right here, well, that would be an issue if we didn't have NBS. So NBS in this case will give you just one product, and I'm going to write heat down. I could have used light, doesn't matter. If you use heat here, the product from using NBS with toluene will give you just the allylic bromination. So that's where that bromine would go on. And so there are other examples you could come up with, but I think this one is the most basic, and it shows that if you have something that's controlled and it doesn't need to be super selective, and there's not very many options for allylic carbons or migration of double bonds, and this is um, a very good opportunity to use NBS.